assignments, doubts, exams. We have got you back. EduPlanner make every chapter easy to understand. Stay tuned, learn more, grow with us.
In this problem, we're asked to examine the possible reaction of an electron and a proton collecting into a neutron and a low mass neutrino. This collection process doesn't occur in our universe at low energies. Perhaps it could be done in a particle accelerator. But if it could, why would this be such a problem for us and the world as we know it? Well, if there ceased to be a separation between protons and electrons, there would be no atoms, basically. All there would be neutral neutrons, and those would just be nuclei. Secondly, if we have just neutrons and no charges in between them, that means with no atoms and all the rich complexity of their dynamics means no chemistry. And no chemistry means no life. And that would be a very boring world, in my humble opinion. Continuing on to part B, we're asked what percent increase in the mass of a proton would enable this reaction to occur at low collision energies. Well, in order to do this problem, we need to look up the masses of our players here. The product here is the mass of a neutron. We've listed in atomic mass units. The reactants are the mass of a hydrogen atom, which contains both the proton and the electron. And we'll want to compare it in order to find a percent increase. We'll have to know what the mass of the protons are presently in order to find how much greater they would need to be to enable this collision to this recombination to happen. But the critical thing to recognize for this problem is that the for this collection of a proton and electron to form into a neutron and a low mass neutrino, we need to know that the total mass of the reactants must be at least equal to the total mass of the products. And in our case, that is the mass of the hydrogen atom, which contains the proton and the electron, would have to be equal, in this case, to the mass of the neutron. So for this to be equal and the electron stays the same mass, the proton would have to increase in mass. It's our task to find out how much this increase must be. So what we need to do is find the difference between the the product, which is the neutron, and the reactants, which is the hydrogen, and and divide that difference, the result of that difference, by the mass of the proton, and multiply it by 100 to get a percentage. Writing that out symbolically, that's how much more the proton would have to increase in mass, the mass difference there. And we're going to normalize it by the current mass of a proton, multiply it by 100, and it turns out that only 0.083% increase in proton mass is would be required for this collapse into a neutron reaction to happen. Okay, and that's our answer. Box that, and I need to go up and box for part A as well.